A programmable logic controller, or PLC, is a computer programming used for industrial automation. These controllers can automate a specific process, machine function, or even an entire production line. The PLC receives information from connected sensors or input devices, processes the data, and triggers outputs based on pre-programmed parameters. Depending on the inputs and outputs, the PLC can monitor and record runtime data such as machine productivity or operating temperature, automatically start and stop processes, generate alarms if the machine malfunctions, and more. Programmable logic controllers are a flexible and robust control solution, adaptable to almost any application. The basic components include the power supply, central processing unit CPU or processor coprocessor modules, input and output modules I/O, and a peripheral device. The PLC's CPU stores and processes program data, but input and output modules connect the PLC to the rest of the machine. These input and output modules are what provide information to the CPU and trigger specific results. Input and output can be either analog or digital. Input devices might include sensors, switches, and meters, while outputs might include relays, lights, valves, and drives. Users can mix and match a PLC's input and output in order to get the right configuration for their application. A PLC program is usually written on a computer and then is downloaded to the controller. Most PLC programming software offers programming in ladder logic, or C. Ladder logic is the traditional programming language. It mimics circuit diagrams with rungs of logic read left to right. Each rung represents a specific action controlled by the PLC, starting with an input or series of inputs contacts that result in an output coil. Because of its visual nature, ladder logic can be easier to implement than many other programming languages. C programming is a more recent innovation. Some PLC manufacturers supply control programming software,